On average, a total of between 200 to 400 tracked objects enter Earth's atmosphere every year. That's about one every day. Thankfully, human populations are rarely affected by things falling from the sky. Satellites travel at 18,000 miles per hour. That means in a given day, satellites can travel the entire circumference of the Earth about 14 times. Digital Globe has 4 satellites around the world at any given moment, ready to take instant pictures of world events. From navigation systems like GPS to scientific research, satellites play a crucial role in our daily lives. But have you ever wondered why satellites fall and where do they go? Let's find out the answer in this video. Imagine a world without instant communication or accurate weather forecasts. Satellites have become indispensable to our modern world. Satellites stay in orbit due to a delicate balance between their speed and Earth's gravity. Think of it like a ball being swung around on a string. The string provides the inward pull, similar to gravity, while the ball's momentum keeps it moving in a circle. However, even at high altitudes, a thin atmosphere exists. This atmosphere, though extremely sparse, creates friction that gradually slows down a satellite's speed. As the satellite slows, Earth's gravity starts to win the tug-of-war, pulling the satellite into a lower orbit. This process can take years or even decades. The rate of descent depends on factors like the satellite's altitude, size, and the density of the atmosphere it encounters. Eventually, the pull of gravity becomes too strong and the satellite begins its final plunge back to Earth. When satellites descend, they don't always land in the same place. Their final destination depends on various factors, including their orbit, design, and the timing of their re-entry. However, there's one place on Earth where many satellites meet their end, the ocean. Earth's surface is dominated by water, with oceans covering over 70% of the planet. This vast expanse makes the ocean a statistically likely landing spot for deorbiting satellites. Furthermore, aiming for the ocean minimizes the risk of debris harming populated areas. Space agencies and satellite operators often plan for controlled re-entries over remote ocean regions. This controlled descent allows them to direct the falling debris away from populated areas, reducing the risk of harm. Deep within the South Pacific Ocean lies a place aptly named Point Nemo. This remote location, also known as the oceanic pole of inaccessibility, is the furthest point on Earth from any landmass. It's a place of profound isolation, earning its nickname from the famous submarine captain in Jules Verne's novel 20,000 Leagues Under the Sea. Point Nemo is not just a geographical curiosity, it has become the final resting place for numerous spacecraft. Over the years, space agencies have intentionally deorbited satellites and other space debris into this region, taking advantage of its remoteness to minimize any potential impact on human life or the environment. From defunct satellites to spent rocket stages, Point Nemo has become a graveyard of space exploration, a testament to humanity's ventures beyond Earth's atmosphere. It serves as a reminder of the challenges and responsibilities associated with space exploration, including the management of debris generated by our celestial endeavors. A desert in the deep, the isolation of Nemo Point. Point Nemo's remoteness is not just a matter of distance from land, it's also a biological desert with very low nutrient levels and minimal marine life. The swirling currents that converge in this region create a kind of oceanic gyre, trapping nutrients and preventing them from spreading. This lack of life makes Point Nemo an ideal location for spacecraft disposal. The minimal ecological activity reduces the potential impact of debris on marine ecosystems. While the debris itself might not be inherently harmful, its presence in a more biodiverse region could have unforeseen consequences. The isolation of Point Nemo also reduces the risk of debris encountering shipping lanes or fishing grounds. This minimizes the chances of collisions or entanglement, further safeguarding human activities from the remnants of our spacefaring endeavors. No-fly zone, navigating the waters of Nemo Point. Despite its remoteness, Point Nemo is not entirely off-limits. There are no international laws or regulations prohibiting ships or aircraft from passing through this region. However, the sheer isolation and lack of any practical reason to visit make it an exceptionally uncommon destination. Ships rarely venture into these waters, as there are no major shipping routes or commercial fishing grounds in the vicinity. The strong currents and unpredictable weather patterns further discourage maritime traffic. Similarly, airlines do not have designated flight paths over Point Nemo. The lack of nearby airports or any navigational aids makes it impractical and unnecessary for aircraft to traverse this remote region of the Pacific Ocean. Section 7. The Circle of Spaceflight from Launch to Oceanic Rest. The journey of a satellite often begins with a fiery launch from Earth, carrying with it the aspirations of scientific discovery, technological advancement, or global communication. It embarks on a mission orbiting our planet, collecting data, transmitting signals, and expanding our understanding of the cosmos. But like all things, a satellite's operational life eventually comes to an end. Its fuel reserves dwindle, its instruments age, and its mission objectives are fulfilled. At this point, space agencies and operators must make a crucial decision what to do with this now defunct piece of technology hurtling through space. For many satellites, especially those in low Earth orbit, the most responsible option is controlled re-entry into Earth's atmosphere. This involves carefully maneuvering the satellite into a trajectory that targets a remote, unpopulated region such as Point Nemo, where its fiery demise poses minimal risk to life and property. Environmental impact, the fate of spacecraft debris. While Point Nemo's isolation mitigates some risks, the environmental impact of spacecraft debris remains a concern. Satellites are constructed from various materials, some of which can be harmful if they re-enter the environment uncontrolled. Metals like aluminum and titanium, while generally not toxic, can persist in the ocean for long periods. Fuels and batteries, if not completely consumed during re-entry, can release potentially hazardous substances into the water. Researchers are actively studying the long-term effects of spacecraft debris on marine ecosystems. They're investigating how these materials degrade over time, their potential impact on marine organisms, and the overall consequences for ocean health. Future of space debris management, a challenge for tomorrow. As we continue to launch more satellites into space, the issue of space debris management becomes increasingly crucial. The growing amount of debris orbiting Earth poses a collision risk to operational satellites, jeopardizing the services they provide. International cooperation is essential to address this challenge. Spacefaring nations are working together to develop guidelines for responsible satellite disposal, promote sustainable space practices, and explore innovative technologies for debris removal. Concepts like space-based lasers to nudge debris into safer orbits, robotic arms to collect and deorbit defunct satellites, and even self-destructing spacecraft designed to minimize long-lived debris are being explored. The goal is to ensure the long-term sustainability of space activities while minimizing their impact on Earth's environment. The ongoing saga of satellites and Nemo Point. The story of satellites and Nemo Point highlights the interconnectedness of our planet and the far reaches of space. From the vital roles satellites play in our daily lives to the challenges of managing their eventual return to Earth, it's a tale of innovation, responsibility, and the need for global cooperation. As we continue to explore the cosmos and push the boundaries of technology, it's crucial to remember the importance of environmental stewardship, even in the vast expanse of space. The fate of satellites, like many aspects of our technological advancements, ultimately rests in our hands. Point Nemo, the spacecraft cemetery, stands as a silent reminder of our past endeavors and a call to action for a future where space exploration and environmental responsibility go hand in hand.